Hey, what's up, guys? Jung here. Uh, okay, today I want to talk about uh this problem here, number 248, uh, Strobogrammatic number 3. I don't know if I pronounced this one correctly. Anyway, Strobogrammatic number 3. Fine. All right, so let's take a look. So, strobogrammatic number is a number that looks the same when rotated 180 degrees. Look at the upside down. Write a function to count the total strobogrammatic numbers that exist in the range of low to high. So basically, you're given like a string with which represents low, and another string represents the high, and you need to return all the any numbers, any strobogrammatic number between this range, right? So what is this number here, right? So and for one, it's one. Okay, sorry, 108, right? Because one, if you rotate 100 degrees, it's also 10 and 8, right? How about two, right? So two, we have some two the white two same thing, right? So 1 1 0 0. No, sorry. So there won't be a 0 0. Notice that because 0 0 is not a valid number. So that's why we're gonna. So we only have 1 1 0 0, and what else, right? And then the rest will be 6 9 and 9 6, right? Because if you rotate this thing 100 degree, it will become the same 6 9, right? Same thing for the 96 here, right? If you rotate this number 180 degree, it will also be the same, right? So that's the numbers, right? Within the range, right? So I think since we're only trying to get uh, until the high here, so there since the high is the same thing, we can write more, right? So with 3 digits, what's gonna be so basically we can always get the digits, the current digit from the previous one, right? So what's this thing here, right? So one uh so three, right? So for three, we need to get from one because we're adding like this two numbers on each side of this one. So it's gonna be 1 1 1 and 1 0 1, right? And 1 8 1 and 1 6 uh no, it's not this. 1 8 1 1 0 1 1 1 and let's see what else. It's gonna be the yeah, sorry. So this thing is here. So for each number, like for each number, we have four options basically, right? What's the options we have? For each one number, the previous one we can add one and one, right? Plus one. Assuming this is the previous number, right? We can add one on each side. But zero we can't, right? I mean, we can add zero, right? But this thing will not give us the valid result because zero, if 0 1 0 is not a valid number, right? But this could be a potential candidate for the following for the bigger numbers, right? Because this, let's say this 1 0 1 0 1, this is a valid number, But when we calculate this one, we still need to count this thing. But when we still need to add this 0, 0, 0 at each side to the to the return array. It's just that when we count this like these numbers, we can just simply ignore any number that starts with 0. We can just simply ignore it. So that's that. And what else? 8, right? If we add 8 on each side, that's still, if assuming this number is the Strobogrammatic number, and then we can add the number on each side with 1, 0, 8, and what else? Like I said, 6, right? 6 and 9. And then what else? 9, 6, right? So with the previous calculated numbers, we can just add, we'll have these 5 options, right? That can give us a, a next level number. We just keep doing it until we see we consume all the numbers, and then in the end we just check among all those possible numbers, any of them is in a range of low to high. That's the most intuitive way, right? And and remember, I think a key thing we want to notice here is when we calculate this number here. Let's say the number is, let's say we give a number 7, right? So when we calculate 7, we can only get a number 7 from n equals to 5, right? Like I said, that's the only way we can get 5. We can get the 7 because every time because we're adding like two numbers on each side. So we can only do the traverse by 2, right? But if we want to get n equals to 6, right? So we have to do a n equals to 4, right? So on and so forth. So it's going to be a 3, it's going to be 2, right? And okay, so with those things in mind, let's try to code this problem, right? How can we get basically the problem comes down to with this range here, we need to get all the possible stro strobogrammatic numbers, right? And where's our starting point, right? Basically, we will get the length of high here, right? Let's say the high, assuming this high has 7 digits, right? So and it will be equals to 7, right? So we'll be having a helper functions to get to pass this 7. But like I said, if you only call this number helper function once with 7, you will only get this strobogrammatic number for 7 digits, 5 digits, and 3 digits and 1 digits. So you'll be missing all the even numbers. So what do? We just simply call the same helper functions one more time with the 7 minus 6, right? In that case, we can get all the possible numbers, right? One for odd numbers, one for even numbers. Okay, I think, yeah, that's pretty much it is. So let's try to code, right? Okay, so first we're gonna have answer, right, to give us the final answer here. And then let's do a mm, high length, right? Since that's the number we will be using, right? Equals to what? Mm, to high, right? And then, like I said, we're gonna have a helper, right? We call the high length and another one, right? To do either, so basically either one of those will be the odd number and the other one will be the even number. That's how we cover all the possible strobogrammatic numbers. hmm So, and then here we're gonna have a defined helper function. I'm gonna call it helper function here. And here we're gonna have number n here, right? So, okay, so first, if, right? Mm, basically if n equals to 0, right? That's the first thing. If when equals to 0, we just simply return, let's do this. Uh, yeah, if it's 0, it's fine. We just return an empty array, right? Empty array, sorry, not empty, array with an empty string here, because we will be needing this string in the following calculation. Because even with the 0, we still need to have like a array here, because later on we'll be looping through this empty string and we'll be adding those 1 and 1 around this thing, right? If we don't have this one, we won't be even enter the for loop later on. Okay, so and then we're gonna have like current uh we call it current answer, right? Current number empty, right? And then we check if n is equal to 1, right? What's the one? For 1, we already know the answer, right? Basically, we can just simply assign that thing, right? So going to be 1, right? And what? 8, right? And 0, sorry, right? So for 1 digit, there are only 3 possible Strobogrammatic numbers here, right? And then else, right? Else is if it's bigger than 1, then we do previous numbers, right? Like I said, we're gonna do a recursive call helper, right? Like I said, we have to give it the n minus 2, right? And then for each previous number here, right? In previous, we'll be adding those 5 possibility numbers here, possible numbers here, right? We let's define like a pairs here, right? So that we don't have to write same logic over and over. I just simply do a array here. First one is 0, 0, right? 0, 0. And then second one, yeah, I'll do a copy paste here. So second one will be 1, 1, right? And then 1, 1, 8, 8, right? And then what? 6, 9, right? And then the last one was what? 9, 6, right? So for each previously calculated number here, we just do and we'll for each pair, right? In pairs, what do? We just add this current number, right? Current numbers append, right? We just append this thing, right? To what? To the pair 0 plus pre number, right? And pair 1, right? That's how we append these things. Okay, and so once everything's done, right? So once this for loop is finished, then we have this like current numbers for this n, right? And then we do what? We just do a current number. We just do a number here. We check if any of this number is within the range of this, right? In current numbers. But I think a little thing to be noticed here, to be careful here is that we have to deal with this 0, 0 here, right? So what do we do here? So first, if, right, if the number equals 0, right, then we know it's a valid one, right? Or if it is equal to 0, if it's not 0, then we have to know if then the first, we don't want the first character of this number to be 0, right? If it's a 0 and it's not, and it's like it's not the 0 itself, then it's not a valid number. So basically we'll skip that. That's why we have a if check here. It's not to 0, right? So that's the first, and then what? And then second one is pretty. We just check the numbers, the range, and if the low int, yeah, low, right? The current number is in the range of our low and high. Int, yeah. Oh, this thing we also need to convert this one to integer because this number itself is also what? It's also a string type here, right? So, okay, so if that's the case, then we just simply, right, we do answer plus one, right? And in the end, we just simply return the current numbers so that this number will be returned to the previous level, right? So in the previous level, the higher level can use this one to do the following things over and over, right? But for each levels, we'll be checking this thing to add it together. I think here, we can do a few. No, okay, let's run this first. In Paris, not in Paris. The Paris. I want to go to Paris, but not here. Paris. Sorry. Pre. Um, yeah. Ah, always forget about these things here. What's the use of all this code if we don't return, right? Cool. All right. See, it passed, right? I mean, I think this I think this is not the most optimal solutions here. But I think for me it's kind of intuitive. I think it's easier to follow. And I think here we can do some like optimizations here. Like, I mean, we don't have to compare. We don't have to compare each number, right? Like every time here, we can just check if this number, the range is inside this length here, right? I mean, I think we can do something like this. Let's say like we have a low length here, right? Equals to what's the length of low, right? So before doing this check here, we can simply do a if, right? If this number length is inside that length range, right? So basically the low length is smaller equals to the number of the sorry, it's not, so basically it's n, right? If this n is inside the range of the high and low, right? And then we can do the check. Otherwise, we know it won't be inside this range, right? So let's do a if check here, and let's see. Yeah, see, it's faster now, although it's not the fastest one, but yeah, I think there's some other things we can check, but I think that's basically pretty much what we can do for now. There might be some other solutions, but I prefer this one. It's easier to follow. And yeah, it's just to recap. So we have a helper functions, and we define the high end, high high length here, and here we're doing the so basically one of them will be odd numbers, the other one will be even numbers, since every time when we will always be uh, reducing the number by 2, because when we use the previous one, we'll be adding 2 numbers on each side, right? That's why we only jump it by 2. And with 1, we already have numbers, but with 2, we're gonna have to use with a number more than 2, more bigger than 1. So we're gonna have like this one. We're gonna use the pairs for each of the previous calculated numbers. We add these pairs on each side, and then in the end of each recursions, we check if those numbers is valid, and then we increase this answer by 1. In the end, we just return this answer. Cool. I think that's it for this question. Yeah, or the problem. Yeah. And yeah, thank you so much for watching the video. I hope you guys enjoy it. And yeah, I'll be seeing you guys soon. Bye.